So the first thing that you need to understand for the net ionic equations is that what we're doing here is we're just basically getting rid of anything that's not involved in the chemistry.
Mm-hmm.
So the only thing that we're actually writing in the equation is the things involved in the reaction. And so, for example, the reason we say this is, let's look at just salt table salt for an example, sodium chloride, NaCl. And so it makes a lattice structure.
Mm-hmm.
And I'm sure your brother Sergeant went over this. So I'm going to make this big circle Cl, and then the little circle be Na. So it basically just makes like this big lattice where you can think of just like a cube basically,
Mm-hmm.
and it's three-dimensional. And when it gets into water, the H2O is going to be attracted to, the oxygen is going to be attracted to the sodium because these guys have a partial positive charge and the oxygens have a partial negative charge, and this guy has a partial negative charge. And so basically the water just grabs onto this sodium and just pulls it out of the lattice.
Okay.
And so basically it's just breaking down its solid shape. So when we add salt into a container of water, what's happening is we're just going to get all of the chlorine and the sodium just floating in the solution, and they're not associated with each other.
Okay.
And so for net ionic equations, usually it involves two different substances that are in an aqueous solution or in a water solution.
Mm-hmm.
And then because these guys can kind of be attracted to each other and they might bump into each other, but because there's water, they're going to be pulled apart again. So they're always floating in solution. But if we added something else that was insoluble and it bumped into one of these guys, then it would form a precipitate or a solid,
Mm-hmm.
and it would go out of the solution. And so that's basically what we're writing when we're coming up with the net ionic equations.
Okay.